Okay, this is chapter 4, test of a single mean. And so we looked at a confidence interval, and you could use the confidence interval actually perfectly well to perform a hypothesis test. You just wouldn't get a p-value from it. Okay, so again, the idea is that in general, we get, you have two things, the real mu zero or possibly the hypothesized one, and you get your x bar from your sample. And in a confidence interval, the idea is that you take your t distribution or z if you have a big enough sample size, and you would think of it being centered over x bar. And if the confidence interval, that say 95% confidence interval, is this big, and and therefore would include the hypothesized mu zero, then in that case, sure, that hypothesized mu zero could be the mean. Now, even if it's not there, it could be, but the chances are less. So, if I get this situation, if mu zero, the hypothesized mean, is in the 95% confidence interval of or based around, we'll say, based around x bar, then what I do know is that my p-value, if I were to calculate it, is bigger than 0.05. Okay, because it's inside the 95% confidence interval, so the p-value would be based on being outside of mu zero, and so there's more than 5% is outside mu zero. And if mu zero is out of the 95% confidence interval, then p-value is less than 0.05. So you could use a confidence interval to do a test of a single hypothesis. But we'll also, but it's nice to get a p-value. Okay, so here is, in this case, our H0 for a single hypothesis, a single mean hypothesis. It's always that the population, it's always that the population mean mu is equal to some guessed mu zero, and the alternative is that it could be a one-sided as opposed to two-sided, but we in this class we're just going to do two-sided, so it's not mu zero. All right, and so then what we do is, again, depending on sample size, but I'll just use a t because we can always use a t, then our p-value is simply based on looking up the probability that our normalized value. So we're going to take our x bar, we're going to subtract the hypothesized mean. Okay, and all we're doing is we're finding how far is it, looking back here, how far is this? Okay, so that's all we're asking there. And then, though, to put it into one of these tables, we need to do it in terms of standard errors. So divided by the standard error. What's the probability that that, now in absolute value, is outside, okay, it's bigger than our t 0.05 over 2 of n minus 1 degrees of freedom. So, you know, how likely is it we're more than this number of standard deviations or standard errors out? And that's the p-value. That's always our p-value. It's always based on that sort of thing. It's just that we had been using z distributions. Actually, in chapter 3, when we did a chi-square, we're using a chi-square distribution. It's just here, you know, you would have, it's a pain to do a hand calculation of the chi-square distribution. Here, not so bad to do this calculation, all right? And so that's all we're looking at, and we get that p-value, and we just decide, well, is it bigger than 0.05 or smaller than 0.05? So one of the examples in the text, they have a question about a nutrition label, okay? And so this is the text's example 4.3 on page, I think it's is it 165? Find the page number here. Yes, 165. So this is page 165 in your text. And what they do, they're just, they're saying, okay, they have a 1 ounce bag of potato chips, and the bag says 130 calories. And 10 grams of fat and so forth, but this is only looking at the calories. Okay, so they sample 35 bags and get what? They get an X bar from those 35 bags of 134 calories. Okay, and they tell us that the standard deviation is 17 calories. And so, you see, the question is, well, is that reasonable? Is 134 calories, given that they say it's 130, is that reasonable? And so they do a hypothesis test, and they say, well, okay, the null hypothesis is that mu is the 130 of the bag that it says on the bag, and then the alternate, based on our data, will be, well, could it be that it's not 130? And so, given these numbers, right, we have, this is n up here, n equals 35. And so, to calculate our t value, t is equal to, and we take our data, so x bar minus our hypothesized mean, mu 0, which is 130 there, divided by the standard error. And so this is 134 minus 130, and divided by our standard error. Well, that was a standard deviation of 17, but then we have to divide that by the square root of 35. What a horrible thing. Okay, but they tell us that they tell us somewhere what happens. You get 1.39. Okay? And so what I need to do is look up the probability, what's the probability that a given t, how did I write that back here? Actually, I wrote that inequality here wrong. I just started nagging at me that I might have done that. That should be less than. Okay, so that oh, I see why I did it wrong. Yeah, because I want absolute values on both of those. Okay, so 1.39 is greater than our t, absolute value of our t. And what t is this? Well, this is our 0.05 over 2 and 34 degrees of freedom. And so, I would use something like Excel, and I'll have a video on that. I would use Excel to calculate that probability. They tell us, now they used a Z instead of a T. And so when they did it, they got an answer of 2 times 0.08, or about 0.16. So I'm going to write p-value here equals, and we should get a number of about 0.16. Okay, and so that in the textbook they use the Z table instead of the T table. Now the problem is our T table, it's not really good for looking up exact p-values. It's good for just checking things. And so, like I say, I'll do a video on calculating p-values using the T distribution, but we'll go with that, 0.16. And so since 0.16 is greater than our 0.05, we fail to reject H0. Now, of course, yeah, fine, but what does that mean? Well, it means we don't have evidence to claim the mean number of calories is different from 130. Okay, so we're stuck with it, right? We fail to reject H0. It means we can't claim, we don't have evidence to claim that the mean number of calories is any different from the 130 that's advertised. Okay, so sounds good. Okay, we'll go with 130. And so that is this idea of determining the p-value for a hypothesis test using the T distribution and a single mean. Okay, so we'll call that video done.